For the longest time, AI has kind of felt like this brilliant high-tech science fair project. Super impressive, but also custom-built and, well, a little fragile. But that is all starting to change. We're moving out of the lab and onto the assembly line. So today, we're going to explore how to build this AI factory of the future, piece by piece.
Really think about that for a second. What if, instead of these delicate systems that need constant human hand-holding, we had AI that was mass-produced, reliable, scalable, and just humming along with industrial-grade efficiency, 24/7, with nobody even on the factory floor? That's the big idea we're diving into.
That jump from a one-off, handcrafted prototype to a mass-market product, it's a massive one, and it's the same exact journey for AI. So the real goal here isn't just making AI smarter. It's about building a factory that can churn out intelligent applications, data, and media, all without a human in the loop. So let's start the tour.
All right, first stop, the factory floor. This is where we see that fundamental shift from one-off lab work to full-scale, automated production.
Now, every factory needs an assembly line, right? In our AI factory, it's an automated one. We call it a headless and synthetic pipeline, and its whole job is to generate all the data and media we could ever need without anyone having to touch a keyboard.
And this quote, man, it just nails the core problem perfectly. In the old way of doing things, getting the right data for testing is just painfully slow and risky. You're waiting around for these sluggish production snapshots, or worse, someone is manually creating fake data. It's a huge bottleneck, where testing, which should be your best friend, actually becomes this huge liability.
So how do we fix this? Well, the answer is this automated assembly line for data. First up, it uses AI to intelligently find and slice out just the data it needs. Then, it automatically scans for any personal info and masks it so everything's safe and compliant. Step 3, and this is the magic part, it generates perfectly realistic, synthetic data that's completely privacy safe. And finally, it pipes that fresh data right into the development workflow through an API, ready whenever a developer needs it.
And the payoff for doing it this way? Oh, it's huge. You get data instantly, on demand. Compliance isn't an afterthought. It's baked in from the start as code. You get total visibility into your data's history and quality. And maybe most importantly, you can spot data drift, when your data starts changing in weird ways, long before it can cause a disaster in production.
Okay, so our factory's got its assembly line humming along. But who gets the keys to the building? Who's allowed in? The next critical piece is a really sophisticated ID system to manage access for every single person and every single machine. Just think about your own life online for a second. You're not just one you, are you? You're an employee, maybe a parent, a student, a customer for a dozen services. Each of these personas has different rights, needs access to different data, and they really should be kept separate. Managing all that complexity is a massive security challenge, especially in an automated factory where machines are making those access decisions in the blink of an eye.
The fix for this is something called a digital identity wallet, or what we're going to call a persona vault. Think of it like a super secure digital wallet for all your different ID cards. It's the master key card for our AI factory, letting you prove who you are without having to show everyone your entire life story.
So here's the clever part. An identity provider gives your persona vault a bunch of verified attributes about you. Then, when some service needs to know who you are, your vault only shows the tiny piece of info it needs to see, nothing more. And because these little presentations are unlinkable, nobody can connect the dots and build this creepy, detailed profile of you across different services. You get total control and total privacy.
All right, we've got our assembly line, and we've got our super secure ID system. Now we need the control room, the brains of the whole operation that watches over and coordinates absolutely everything. This is where orchestration comes in.
And the scale we're talking about here is just staggering. It's not unusual for a single company to be juggling 500 different active workflows using a platform like Make.com. Imagine hundreds of apps and services all needing to run in a perfect, intricate sequence. This is way beyond something you can manage on a whiteboard.
And if you look at a real-world architecture for an enterprise AI platform, wow, it gets complicated fast. You've got all these different components for managing data, for training models, for deployment, for analytics. It's a huge web of interconnected parts. The job of this control room, this orchestration platform, is to make all these moving parts play together in perfect harmony, like a well-conducted symphony.
Okay, we are almost done with our factory tour. We have our production line, our security, and our central control room. But there is one last, and I mean essential stop, quality control. How do we make absolutely sure that what comes off our assembly line is perfect every single time?
In our AI factory, the #1 defect we're hunting for is something called configuration drift. And what is that? It's when the system that's actually running in the real world slowly starts to look different from its original blueprint. It's like a tiny crack in the foundation that just grows and grows until the whole thing comes crashing down.
So how does this even happen? Well, it could be something as simple and innocent as this command right here. A developer manually scales an app up to handle a bit more traffic. It's a quick fix, sure, but it's an untracked change. The system has now drifted from its official design.
Or maybe it's this. Someone updates a piece of software directly on the live system to patch a bug. Again, seems harmless, but now what's running in production is out of sync with what's in the code repository. Another tiny crack.
It could even be a developer just changing a single environment variable to test something. These small manual tweaks, they pile up over time. They create a system that's fragile, unpredictable, and an absolute nightmare to fix when something goes wrong. This is exactly the kind of defect our QC system has to catch.
So how do you catch this stuff? With an automated QC system, like this one from DriftGuard, it is constantly comparing the live system to its blueprint, and it flags any mismatch instantly. And what I love about this is how clear it is. No dense log files to dig through, just simple emojis that tell you the status at a glance. You see the rocket for startup, the warning sign for drift, the check mark for when it's fixed. It's brilliant, simple, and completely automated.
So let's just take a step back from our factory tour and look at the whole picture. We've seen the automated assembly line for data, the super secure ID system, the central control room, and the automated quality control. What does it all mean when you put it together?
What it means is we're finally building a new kind of infrastructure, one that's designed to manufacture intelligence. By applying these industrial principles, AI stops being this fragile, experimental thing we have to handle with kid gloves. It becomes a reliable, predictable factory that can scale to incredible heights without any human intervention.
And that leaves us with this one really huge question. For pretty much the first time, we're building the tools to produce intelligence, data, and digital media with the same kind of efficiency that we build cars. The how is getting solved. The real question now is, what are we going to choose to create with all this power?